Hello, everyone, and thank you for joining today's webinar. We are partnering with GitHub to bring you this webinar, and we're really excited about it. I'm going to hand it right on over to Chris, and he's going to take it away. There you go, Chris.
Hey, everyone. Can you hear me okay? Can everyone hear me?
Yes, we can hear you. You're good to go.
Perfect. Everyone, I'm Chris Rondeau. I'm the Application Security Executive here at GitHub for public sector and also East Region. I've been in the application security space for over a decade. Previously worked at a company called Veracode. We did compiled binary scanning in the cloud. And I joined GitHub in 2001. So it's nice to meet you all, and I really appreciate you joining to learn a little bit more about GitHub and GitHub Advanced Security, and also kind of our partnership with Xebia and Xpirit. For today's webinar, we're going to talk a little bit about kind of GitHub Microsoft, that partnership, and what we're doing in the application security space. And then for folks who may not be completely up to speed on AppSec and why it should matter, I'll talk a little bit about that. Some of the software development lifecycle methodologies and security scanning evolution over the years, and why GitHub makes sense in today's modern software development. Some of the historical challenges around implementation, adoption, and maturation that I've seen in my 10-year career in application security. And then what is GitHub Advanced Security and why it might be a good solution for you. And then we're going to have David from Xpirit give you a technical demonstration. So we'll save questions for the end. If you want to ask questions in the chat, please do. We'll certainly go ahead and answer those as we go along. So thanks again for joining. So you guys probably all heard of Microsoft, but in 2018, Microsoft acquired GitHub. And Microsoft, as you know, is a Azure development, an ADO organization, right, that all of their software developers used. They acquired GitHub for $7.5 billion. At that time, we had 28 million users. So that was only, 5 years ago or so. And then Satya Nadella is Microsoft's CEO. They are moving their entire software development team onto GitHub. And that's really going to be the home for every software developer within Microsoft. But it's also where Microsoft is investing the lion's share of its resources into GitHub and away from Azure DevOps. And you'll see a quote here from Amanda Silver, who's the CVP of product for the developer division at Microsoft, that GitHub is the North Star, right? So it's really their long-term vision is to have their engineering team on GitHub to improve developer productivity. And by leveraging the GitHub platform, they'll enable Microsoft teams to embrace an open source culture, practice, and tools, and bring them into inner source as well, right? So just again, some validation from top Microsoft leadership around the interest and investment in GitHub. So from a GitHub perspective, we've got over 100 million global developers now and growing literally every day. I have to update these numbers every time I give a presentation. But we've grown from 28 million, as you saw on the previous slide, now to over 100 million in a very short period of time. And a lot of people think of GitHub as kind of the open source repository for collaborating and sharing code. Most of our users now are on the private side. So you have the capability of using GitHub in a kind of a walled garden where all of your data and code is secure, both in rest and in transit as well. So it's really the most popular developer tool on the market, and again, growing. We actually issue more CVEs for open source software than all other security vendors combined in 2022. We're the second leading CVE issuing authority, only after MITRE. So CVE is a common vulnerability exploitation. It's an acronym. Basically, anytime there's a vulnerability found in software components, they give it a name, give it a number, and that way folks can kind of identify what they have in their code that might be vulnerable, right? So we're the second leading CVE issuing authority, only after MITRE. And then we've allowed our developers to fix more than 24 million vulnerabilities as of 2022. So what is application security? Why should it matter? I'm not going to spend a lot of time for folks who are understand what AppSec is and live this and breathe this every day, but just as a kind of a way to level set with you all. So AppSec refers to the hardening of software that performs a variety of tasks, from banking to shopping to doing work. The software uses a combination of code that is written internally, first-party code, and code that is open source code or third-party code, right? Most applications today are comprised of that third-party code nomenclature, right? So you think of an application, some of your developers write maybe 5 to 10% of that code. The rest of it's been written by somebody else. So it's just easier for developers to leverage that third-party code. It's faster for them to get their applications into production, and the business can start earning money or earning whatever once it's in production, right? So the goal is pretty simple. It's to remove security threats from software so that it cannot be used by malicious hackers or abused with very bad intentions. So flaws in applications are now consistently the #1 attack vector for security breaches. Over 80% of web applications related breaches can be attributed to stolen credentials. Challenge with AppSec is usually you have one security professional to 100 developers. So the scale is pretty challenging for security teams. And in our experience, people that are responsible for application security wear many hats. And it's not just AppSec, it's one of many things. So they need a lot of help on the services front as well to help get their application security programs kind of up and running and successful. There's really a lack of secure coding knowledge amongst the developers. So most developers are not taught about secure coding in schools or as they grow up, right? It's just something they're having to kind of glom onto once they start their professional career. And then the remediation trends or finding the vulnerabilities and fixing them are pretty stagnant. So we're seeing most findings taking 6 months or so to fix, even with like some of the severe and critical findings in applications. So a lot of challenges that have currently exist and have always existed in this space. So let's take a look back. You had waterfall. Waterfall is a type of software development. And it was really prevalent in the 70s when software development really was kind of getting started. So you had maybe 1 to 2 releases of an application per year. And those were largely on-premise security tools, right? And so developers would write code and then write another application and maybe write a third application, and then they probably wouldn't review that code again for another year, right? So they kind of lost the context of what they wrote and what the application was doing. So it was a great methodology when it was developed, but as the tools got better, as the processes got better, you had something called Agile pop up in around 1993. So instead of 1 to 2 releases per year, as with Waterfall, you get 1 to 2 releases per month with Agile. And that was mostly on-premise security tools as well, right? On-prem meaning no internet connectivity, nothing with the cloud, none of that existed, right? It was all like in your environment. I'm definitely showing my age when I say that. With DevOps, right, 2013, you had 1 to 2 releases per week. So things were starting to move a little bit faster. You had both on-prem and cloud security tooling. Veracode, again, was like the first to scan compiled binaries in the cloud. It was a great solution for the time that it was created. And then you had CI/CD, which was really like continuous release, continuous deployment, continuous integration, continuous deployment for 1 to 2 releases per minute. And so that's on-prem plus cloud security plus like even like FedRAMP requirements, right? We're kind of all kind of encompassed in that, or could be. And so you think of like your high velocity developer shops like Netflix or Etsy, like they're literally producing code like every minute. It's insane. All right. And so you had to have the right people, process, technology to be able to write code, secure code, to push that into production so customers could use it, and it was also secure so they weren't getting hacked. Right. So at each stage, and again, the point really on this slide is just to share that like at each kind of era and each stage, like the tools kind of match the era in which it was created in. And we'll talk about why GitHub's a little bit different and why it makes sense for more modern software development. So some of the historical challenges around implementation and adoption of application security. So you have your development folks, your software developers, you got your security team, and you have your operations teams, right? While they might be under the same organization, they work typically in silos. So they don't always collaborate. They don't always share information, although that's changing. Some organizations do it better than others. As a general statement, you can see these silos still exist, right? So you have developers that are writing the code, delivering features on time and within budget. You've got your security folks that are making sure that the applications are secure and they meet compliance, whatever the compliance may be. Again, if you're federal, if you're financial services, if you're healthcare, you've got different regulations and compliance requirements for your applications, right, before they can technically go into production. And then you've got your operations folks that just want to make sure that the applications run reliably. So you've got these DevSecOps teams kind of working together, but not working together, through the application security process and software development lifecycle process. So with more modern software development, you've got more developers now running all the security scans. So not only developers kind of responsible for developing the applications on time and within budget, they're also now kind of required to run the security scans themselves. And so we talk about static code analysis, which is scanning your applications for the first party code that you developers write. You've got software composition analysis to scan those third party components that they're bringing into the applications. You've got dynamic analysis, which is like a web scan. It runs like a web crawler that looks at your external facing web applications. It gives you different results, different vulnerability results. You've got IAST, interactive application security testing, runtime applications, like all these 4-letter acronyms of testing that now are kind of at the fingertips of the developers, right? So it's a lot of pressure on the developers who are already under pressure to be able to do all these types of scanning. And that's kind of the way it's been done for the last, I would say, 10 to 15 years. Used to be some of the security teams would run scans themselves. Now, if you see that, it's really kind of a small shop, or it's really kind of a legacy system or policy in place. We don't see that much anymore around security teams running scans. It's all developers, like 100%. So the security testing has historically been a gate that has stopped down or slowed developer momentum, right? Developers get into this kind of flow state where they're grooving, they're moving, they're developing code. Anytime they have to context switch, right? Meaning they have to like stop what they're doing, go from an IDE, a developer, tool to like a Jenkins build to a Jira ticketing system to another web UI to get results to another web UI to get different results. Like that just slows developers down. And security typically has been the ones who say, we're going to stop your momentum. We're going to review the results of the scans that take place. We're going to require you to go fix them and then come back and rerun the scan. And if it passes the security test, then we can push it into production, right? So it's act as kind of a bottleneck. It's really slowed down developer momentum. And that's been also a reason, and largely the reason, to cause friction between developers and security teams. And that's largely as well because of the type of technology and processes that were in place for the last 20 years have kind of contributed to that bottleneck, right? And again, we'll talk about how GitHub is different, how GitHub is not slowing down developer velocity, and how the security is really embedded in the scans themselves, and how we're actually doing it better to help increase that velocity, help keep that developer in the work in the flow state, but also add security and making sure those applications are secure before they go into production. And then you've got so many tools that are out on the market too, right? This is like a periodic table of tooling that I like to share, because oftentimes when we go in and talk to our customers, they've got literally every tool under the sun you can think of. And that becomes very difficult to manage. It's very expensive. And so when we start to see more and more organizations kind of consolidate onto GitHub, right? You'll see Visual Studio there from the Microsoft, like Azure DevOps folks, right? There's so many like different tools. In addition to penetration testing, you mentioned like MPT. MPT is like your ethical hackers that sit on your systems that look for vulnerabilities and then help your teams kind of remediate those. So those are like the expert folks that are kind of reserved for the very business critical applications that have very sensitive information. It's very expensive, but they're amazing, but they can't be kind of scaled across thousands of applications. They're usually like reserved for kind of a subset of applications. But having said that, right, like there's just so many tools under the sun. Like, how can you do DevSecOps effectively if you got different teams using different tools, doing different things, right? So we're starting to see more and more organizations considering GitHub as an example to help consolidate that. So you've got your DevSecOps teams on one tool to be able to do all of these things more effectively. And we'll talk again how we integrate with some of the other solutions, even in some of our competitor solutions, right? To make it a much more kind of easy to use and simplistic tooling for our customers that include security as well. So this puts pressure on security teams to pick the right tools, right? So security teams typically make up about 80% of the buyer of application security tools, right? They usually have the budget because they're security. But they have to kind of play nicely with the development teams because the developers are writing the code and the developers are securing the code, running all the scans themselves and the tools that they use. And so if you've got a security team that hasn't included all the developers in a trial or proof of concept, right? Or maybe they had a small subset of development teams, right? That they selected a tool. Once they get to actual implementation of that tool, if you're a developer and you haven't participated in that trial, or you love a different tool, or you're just not happy with the tool that's been selected, right? Like it causes friction. And so a lot of the onus and responsibilities on the security team to pick the right tools, and they've got the budget. So they're the ones that are trying to figure out like, all right, which tools are best for our development teams that also meet our security criteria. And so you'll see a lot of tool choices today kind of fall under the marketing guise of shift left. You'll hear a lot of like shift left, right? And the idea there and the concept there is, as developers are writing code, you want to be able to scan that code for vulnerabilities and be able to fix those earlier in the software development lifecycle versus like waiting until the very end of like their kind of production life and trying to scan it there. And at the bottom there of this graph, you see kind of the average cost. And sorry, the slide here kind of dorking up my numbers, so I apologize for that. But basically, like the earlier you can test and fix these vulnerabilities, the cheaper it is, right? And the concept is solid. The challenge is when you have like scans in an IDE, right? As a developer's writing code and they're scanning the code, they're scanning like class files or really small files. And while they're getting really fast results, they're getting a lot of false positives because the applications themselves, it's not a full source to sink taint analysis of really analyzing what the application is doing or calling. And so the scanners tend to flag stuff that's not actual vulnerabilities. And so the developers, while they're getting great, fast results, not great results, but getting fast results early, they're having to sift through those results to figure out what's a true positive from a false positive, right? And false positives have been the bane of existence, especially in static code analysis for 20, 30 years. And so we did a retrospective back in the day of kind of a scanning in an IDE tool. And over a 3-year period, we saw less than a 2% adoption over time. And while it sounds cool and a lot of marketing dollars have been spent on shifting left, the actual results have been really, really poor. And so GitHub has taken a completely different approach around allowing our customers to scan on commit, but also around the pull request. And the pull request is really kind of when the DevSecOps teams come together and huddle around the results of a scan to then also be able to kind of discuss how best to remediate it. And so teams get together anyway, and they're going to huddle. So the PR is like the perfect time to do that. We actually see a 72% remediation rate upon scanning and fixing around the PR, which has been awesome. So we don't scan in an IDE at GitHub. There's tools that do that out there. And if that's your jam, go for it. But I guarantee you're going to run up to a point where if you're scanning in an IDE early, you're going to run into this false positive problem, and it just leads to a lack of developer adoption. We'll talk about developer adoption and why that matters and why it's critical to your application security program success. So now this, all these different tools in your environment, this whole shifting left theory, what happens then if you've got all these tools, it's very expensive. And so organizations don't have unlimited budget or unlimited resources. So they tend to prioritize what they actually fix, right? So they do that from a couple of different angles. One is they prioritize the applications they want to scan. It's usually the business critical applications in their entire portfolio. And those tend to be, again, the ones that have business critical or personal information, PII, PCI, all the 3-letter acronym sensitive stuff that customers care about and they can get fined for from a regulatory perspective. And so they tend to scan maybe less than 10% of their entire application portfolio using the old kind of multi-tool, budgeting process. And they also, from the second point of view, is they tend to focus just on like the high severity, right? And so they leave some critical, they leave some high or medium vulnerabilities, right? And in some cases, you can string multiple medium or even low flaws together to create a much more kind of severe vulnerability. So they tend to prioritize what they fix, right? And that makes sense. But prioritization is essential because it also leaves a lot to be desired, where 50% of the flaws are still open after 6 months and 25% of flaws are still open after 1.5 years. So it creates an entire backlog of vulnerabilities that are still sitting there that haven't been fixed, right? So you've got the multi-tool problem. You're spending a lot of money. You're securing less than 10% of your applications, and then you've still got open flaws just kind of hanging out there, waiting to get hacked, right? That's the gist of it. When I was at Veracode, they had this slide that I've been able to lift publicly, which I think is a good way to show you kind of where an immature AppSec program is, and that's in the upper left column, versus a mature AppSec program, which is in the bottom right column. And not all organizations are like this, but basically the pink here is kind of the open open vulnerabilities or open flaws that are still sitting there after a certain period of time versus, number of scans, and then the number of fixed. So you can see there's a lot, like the iceberg here is a lot of still open flaws versus actual flaws that have been fixed, right? And so the premise is that the more you scan your applications, right, and organizations that scan more tend to fix more. And when we kind of dug into that, we asked, why is that, right? And it's typically because the organizations that scan more are more of the modern kind of software development shops that tend to be kind of early adopters around the newest and latest technologies. And they're also kind of incorporating and automating the scanning that takes place within the SDLC. So there is a correlation with higher scan frequency and fewer flaws, right? That are also critical to success. So at GitHub, we've actually tried to shorten this gap between 1 to 3 annual scans and 300 plus annual scans to say, all right, how do we then, even if you want to scan 1 to 3 times annually, right? How do we get those numbers closer? How do we reduce that security debt in that iceberg, right? And that's through the automation piece within GitHub. So you can automate all of your scanning, whether it's SAST, DAST, SCA, IAST, RAST. Again, I'll go down the list of 4-letter acronym scanning security solutions. You can automate all of that. And again, having it at the PR for your DevSecOps teams to be able to identify and fix is critical to reducing that security debt. And then the application landscape is changing. So you see a lot more applications now being built. A lot of monolithic applications, very, very large applications that have historically existed are kind of moving into microservices, like smaller pieces of applications. And so being able to create those and scan those and making those secure have exploded. And then I saw an article recently, and Microsoft and GitHub have published also that the advent of AI is going to absolutely explode the application landscape. So there's going to be 5 times the number of applications written vis-a-vis AI, I think, in the next year than have been developed in the last 5 or 10 years collectively. So AI is absolutely contributing to the explosion of applications, which means, again, it's going to increase the threat vector. And so, again, securing these applications, even based with AI, is critical for your organization's success and clearly to keep your application secure. And then, the global pandemic, we're a few years removed from that. It's still kind of lingering, the impacts of that, right? But with digital transformation, you had a lot of kind of classic brick and mortar companies moving to the cloud now, right? Because they had to go digital to survive their business. And, I don't know if you've been to a mall lately. There's hardly any shops in there now. It's like a lot of folks walking around and trying to get exercise versus actually shopping. But anyway, a lot of companies now have moved to the cloud. With digital transformation, you still see the security threat. So you actually see in a recent survey, 58% of the respondents increased their security budgets, right? Because it had an impact on their business. So they made that a priority in their budgeting process. And then 82% planned on adding security staff. And then 81% felt the pressure to lower security costs. So it's like there's a growing need, growing importance for the business. They need to add staff, but they also want to cut costs, right? So kind of, again, that multi-tool, multi-budget, expensive formula to only scan less than 10% of your applications just doesn't make sense on any level, right? So this is why we're seeing a lot more people really kind of turn their attention to GitHub and look at the value and impact that GitHub can help make. And then, as we've seen, with more code equals more problems, right? So as you've seen an explosion of microservices, AI coming into the mix, you're going to see more code being produced, but that code is still insecure, right? For all the reasons we just discussed. So we see a close correlation between, more code equal more problems. And then at GitHub, right, because you've got your code in GitHub, we can actually see secrets, like leaked API credentials or tokens in your code as well. And so we're seeing more credential leaks than ever, and we're seeing folks try to work all sorts of nefarious ways to steal your access tokens to get into your systems. Excuse me. So we talked about open source components, right? Comprising, 90%, 95% of your applications. 98% of proprietary applications contain around 90% of open source code. Of those applications, there's an average of 528 open source components per application. And of those components, 50% of those are more than 4 years old, right? So they haven't been patched or fixed, and they're probably vulnerable. So almost 80% of the time, those components are not even updated. So when you have crises du jour like Log4j, WannaCry, Ghost, Heartbleed, you name it, struts, Apache struts, right, with the Equifax hack. When those things happen, and they're going to continue to happen, we see a lot of AppSec teams really working late hours and weekends, and using expensive software engineering resources, right? People that make, good pay and good benefits, kind of stopping everything else to focus on these particular vulnerabilities that end up, coming up. So we saw an average cost of about $20,000 per patch, right? Think about that across your entire organization, across all the applications that have this particular vulnerability, right? And later for the demo, you'll see David talk a little bit about our Dependabot solution. When Log4j came out, if you've got all of your code in GitHub and something like Log4j comes up, you can literally you'll get an alert from GitHub saying this critical vulnerability has just been released. It's in these repos and in these applications. Go fix them. Go get rid of them, right? But you can also type in literally Log4j into GitHub, and it will surface all the repos, all the applications where those vulnerabilities exist. So it's a really quick and easy way to kind of surface where these vulnerabilities sit within your entire tech stack, assuming they have it in GitHub, right? We've talked to customers who have said, if we didn't have our code in GitHub, I easily would have spent 200 to 300 man hours trying to find out, where in our code base that Log4j vulnerability sits, right? But because they didn't have GitHub, right, they'd spent the long weekends, long hours, trying to find it and patch it. So this is a kind of a nice summary of the classic, I call them classic AppSec security challenges with people, process, technology is kind of a framework to look at the problem. I'll highlight the ones here in red. There's typically the friction between developers and security team members, again, because they sit in different teams, different silos. Security teams kind of the gate before applications can get into production. So that kind of friction still exists, right? It's an interesting relationship. Let's just put it that way. There's been a lack of developer adoption around certain tools because either they're not fast, they're not easy to use. Developers have to get out of the flow. They're context switching, right? So that you don't see developers really going all in on security tooling. And then we see that lack of developer secure coding expertise, which creates challenges. So if the tools don't have explanations of what developers are seeing from a vulnerability perspective or how to fix them, right, or examples of good or bad code, it just doesn't help. So developers are having to go on the web and Stack Overflow and figure out how to fix these things. It's not good. From a process perspective, you've got developers managing too many commercial products for security, for SAST, SCA, DAST, IAS, RASP, right? Again, just too expensive, doesn't scale, slows developers down. It attributes to that friction between teams. And then on the technology side, you see, again, managing too many false positives from the security tooling, which has been the bane of AppSec and static code analysis specifically for many, many years, right? And again, David and our team can talk a little bit about how we're GitHub and our CodeQL SaaS solutions a little bit better at doing it than every other tool on the market. And then I will just add another one that I don't have highlighted in red here, which is it's right now AppSec is an innovation game. It's an investment game, right? And you see a lot of legacy companies who are kind of, I think they've already reached their peak and you're starting to see them in a major decline. They've been bought out multiple times by multiple private equity firms. And I'm not going to name names, but you can do the research. And they're just not investing in the products like they should be. What they are doing is extracting as much value out of the existing contracts as they can. And so it's kind of a double-edged fall from my vantage point. And so what I love about GitHub, and one of the main reasons I joined GitHub, was because of the Microsoft investment and backing. And so they're investing a ton of money and resources into making the best possible developer experience for security with GitHub and advanced security, right? And you see things like Copilot for Business. Copilot is our product that it's AI generative, built on ChatGPT, OpenAI, which is all Microsoft funded. We added another layer of learning language model to add security to that and developer coding experience. So as developers are writing code, they're writing better code faster. They're getting generative AI prompts about how to add different frameworks, add different language capabilities, all sorts of cool stuff. And even with chat, right? So they're just writing better code faster. And then we're going to be releasing a product here soon around AI for advanced security. I can't really speak too much to it, but we're really excited because it's been kind of the holy grail in AppSec for 30 years. And it's basically, as developers are writing code and you want to talk about shifting left, right? as they're writing code, they're going to get a generative AI prompt around how not to, inject a vulnerability into their code, right? So we're really excited about the investment and where we're going as a company. But again, this is an investment game. All right. One final observation is kind of the problem of political capital in DevSecOps. And what I mean by that is I talked earlier about kind of 80% of the spend coming from the security team, right? They have very little influence typically over the developers processes, developer skills, developer training. But security purchases those tooling for, right? And you can see kind of there on that graphic, the things that are, activities for successfully implementing DevSecOps rank 1 through 6. You've got integrating and, automated security testing, obtaining DevSecOps stakeholders, training staff, identifying secure DevOps champions. Like a lot of that is like change management stuff, right? That's important, absolutely important, right? But you see kind of the political capital challenges that the security team is invested in making that tool that they bought and approved successful. And so even though it may not be the best tool, right, they're committed to making it work for 1 to 2 to 3 years, and sometimes at a high political cost. So what I like to, when I talk to security folks specifically, I like to say, like, look, you're probably tired of the developer adoption challenge, and you're tired of the friction. And if you've been doing AppSec long enough, right, like there is a better way, and that better way is GitHub, right? Because developers love GitHub, and you've got security now built into the tooling, and it's automated. And by the way, you can pull in other tools that you may already be using, like a SonarQube or a Veracode or whomever, right? Like you can plug those in and use those as well with an advanced security license. So we can make the consolidation play easier for you. It's cheaper. But if you want to use Veracode for COBOL or RPG or some like antiquated language that GitHub Advanced Security does not support, go for it, right? But you don't have to spend that much money to be able to do that. You're actually going to cover more of your application portfolio within GitHub and GitHub Advanced Security. So to me, it's also like you're making this smart political decision with GitHub because you're going to win goodwill and influence and credibility by picking the smart solution that your developers are actually going to love and use at the end of the day, right? So there's only one thing you remember from this presentation. It is this, and I hope you're all paying attention. The success or failure of your organization's application security program will be based on developer adoption of your security tooling choice, right? Like you're not going to have success with an AppSec program unless your developers are using the tool and adopting it, right? And that old model that I talked about with the IDE, the Jenkins, the Jira, the different web UIs they have to go to, that doesn't scale and it doesn't lead to developer adoption. Within GitHub, everything's there in one spot. You're going to have a much higher developer adoption rate. And more importantly, you're actually going to surface and fix more vulnerabilities at the end of the day. So really, it's all about developer adoption if you want to be successful. So what is GitHub Advanced Security? And I'll make this quick, and we'll hand this over to David here shortly. 4 key pillars. We've got our security overview, which is kind of your 30,000 foot level view of, which repos we have advanced security turned on, which of the solutions have been enacted, and then ultimately how many vulnerabilities we found per repo based on the security solution themselves. If you've got other third-party tools that integrated into GitHub with the advanced security license, you can pull those into the security overview as well. And then, of course, everything we do is based on API and webhooks. So if you want to output, results into another SIEM like a Sentinel or Splunk or some other, GRC, you can absolutely do that, right? Whatever makes sense for your organization. We've got, you can get kind of 2 ways, right? Within GitHub, and then you can export it elsewhere. We've got Dependabot. That's our software composition analysis solution. Again, that looks at those third-party dependencies that comprise 90 to 95% of your applications. Again, we're the second leading CVE issuing authority around that. We've got, easy ways to surface those dependencies and fix those quickly versus some of the other tools where you have to scan each individual application and understand licensing and versioning and all that good stuff. Like if your code's in GitHub, we turn on advanced security, we surface that stuff like now. It's all there for you to see, and it's easier to manage again around the pull request, which is awesome. CodeQL, that's our static code analyzer. David will talk a little bit more about this specifically, but we do it differently. It's the latest generation of static code analysis. We can actually hook into your compiler during the build time, and we create a representational database of your application. We do a full source to synctain analysis. We see exactly what the application's calling, so you're actually getting actual vulnerability results versus a list of flaws that might be vulnerabilities, right? What does that mean? So we'll find like 10 actual vulnerabilities, so it's highly tuned, versus 100 results from the other tools of flaws that might be vulnerabilities. So in the other, other tool category of those 100 results, developers have to sift through those results, figure out what's a true positive, a false positive, send that again to the, the security team to review. It's a mess, right? So with CodeQL, highly precise results, developers that can go and fix it and move on with their day. Again, much higher developer adoption, which is going to be critical for your AppSec program success. And then they can move on and do other things, right? And then we've got secret scanning. Secret scanning, again, once you have advanced security turned on, your code's in GitHub, we can surface those leaked API credentials and tokens right away. So you can rotate and revoke those immediately, right? And again, you've got the third-party integration stuff that I've talked about ad nauseum. At the end of the day, outcomes are improved developer engagement and productivity. You've got faster innovation, things are happening faster, and things are more secure, right? You've got a reduction in tool integration and cost, right? And maintenance efforts. So we offer both a cloud variant and an on-prem variant. You can do both. You can have both options within your environment, right? Again, all kind of a walled garden and secure from that perspective. And then the risk reduction is really the name of the game here. And we talk a lot about kind of reduction of costs. Like, I can't stress that enough. It's not just about the cost piece, but it's about consolidating folks onto an incredible platform, an incredible product where you can kind of leverage our native capabilities, but also integrate some of the stuff you may already be using. And then we talked about the innovation. Just excited about Copilot. It's absolutely exploded. We have people calling us, asking us for demos all the time around Copilot. We're seeing, it's suggesting now 70% of newly written code, which is up from 35% already earlier this year. And I mentioned our AI for advanced security product, which we'll be releasing very soon. More details on that. I'm really excited about that. It's, again, been the holy grail in AppSec for 30 years. Really excited about kind of being at the forefront of that with a solid product, great investment, great backers, and just leading class technology around that. Guys, please call me, reach out via email. We'll set up some time to do, have some further discussions. And I've got different folks in different regions that can talk to you globally. So if you have questions or want to see a demo, really kind of want to, kick the tires and test it, absolutely, we'll set that up for you. So I'm going to stop talking. I talk fast. I appreciate your time and attention. And we'll save questions for the end. And I'm going to hand it over to David. Thanks.
All right. So for this demo, we are using the GitHub Advanced Security Workshop. This is free repo open source that you can find in the Advanced Security organization. So you can go to github.com/advanced-security/gas workshop. In this case, I already cloned this in my organization. So as you can see here, this is basically generated from this template. So from this one, what we're going to see as part of this demo is, first of all, how to turn on the GitHub Advanced Security that Chris was mentioned. So for that, I need to be admin of the repo. I need to go to settings. In settings, we have here this code security and analysis. And from here, we can see all the different features that Chris was mentioned. So we have the vulnerability reporting. That is a feature that is right now in beta. I'm going to enable that. Now we have the Dependabot. Dependabot is basically to scan all the different packages. As Chris was mentioned, around 80-90% of the code that we have are coming from basically these different packages, NPM, NuGet packages, Maven, and so on. So we really need to scan these packages to see if there are vulnerabilities in those. There are different features that we can turn on here, like, for example, the Dependabot alert, just to get an alert when there is a vulnerability that was found in one of the packages. I can also turn on security updates. The security updates basically allow us to receive an open pull request from Dependabot in order to fix the issue that we have. So we are going to enable this as well. And we also can turn on the version updates. This is a more flexible approach when I want to receive a pull request because there is a new version of the package, not necessarily require something for security, but just a new version of the packages that I have. So this will create a Dependabot.yaml file. So I'm going to just leave that one as it is. Something important is that GitHub Advanced Security is not just about turning on these features and that's it. It's beyond that. I need to know how to react to these alerts, how to triage these alerts, basically how I can like measure the security coverage that I have in my code, and something like that. So as you can see, as I turn on these features, right now I'm getting alerts in the security tab. So I can go for the code scanning. Code scanning is basically find vulnerabilities in my code. So now we have coverage in the packages, and also I can turn on code scanning for the vulnerabilities that I have in the code. As Chris was mentioned, this is part of the CodeQL feature, but I can also integrate other third-party tools. So if we explore basically what workflows we have available here, we can find out that we have SonarQube, Sonar Cloud, we have the Red Hat Code Ready, we have check marks, and so on. So I can basically integrate the code scanning solution with other third-party tools. So I'm gonna set up the CodeQL. Right now, as you can see, we have the default option, and we have the advanced option that is basically creating a YAML file for running a GitHub action with CodeQL. So I'm gonna use the YAML file, but if I have the default option, you can see here that it's basically identifying the languages that I have, the query suites that I'm doing, and when I want to enable these basically code scanning. In this case, by default, is when I have a push and a pull request. With the option of doing it in a more advanced way, basically have more flexibility. So as you can see here, the CodeQL is detecting the languages that I have in this repo. So in this case, I have Go, Java, JavaScript, TypeScript, Python. So I can enable code scanning for all these languages to create a matrix. So it's basically running each of these jobs that I have in the action workflow for each of the languages that I have. So I'm going to enable that, commit changes, commit to the main branch. That's okay. And that's it. Now I have the code QL enabled as well. So if I go back to the settings and code security, the last feature that we have is secret scanning. So for secret scanning, I'm going to enable this feature. This is to detect when there are basically password, credentials, connection strings, everything that basically represents secret, it will be a scan. This will scan the Git history. So it is not only the latest commit, but it will scan all the code base that I have. And as part of secret scanning, I have also one feature called push protection. This push protection is to go one step further to avoid secrets being leaked at the moment that I'm pushing code. So it's basically when I'm doing a commit, I will receive an error saying that there is a code, a credential basically exposed. These are through the supported secrets that we have. So GitHub supports all these secrets. As you can see, we have secrets from Adobe, AWS, Azure, and so on. So yeah, definitely I want this feature as well. So I'm going to enable that. And as we turn on these features, something that I was mentioning is that, I mean, we need to know how to react to these security alerts. So as you can see here, we have the dependable alerts, and we have the secret scanning. For the code scanning, the action is right now basically being executed. So that's why we are not getting alerts yet. This is basically creating the database with all the different alerts that we have for the different languages where I decided to run this. So if we take a look at the vulnerabilities alerts that we have for Dependabot, you can see here that we have a category of the critical, high, low alerts, and so on. So yeah, as you can see here as well, we are getting some pull requests. These pull requests basically provide a solution to update the packages for us. So in this case, we have an npm package that is basically affected version. We have here the patch version is the 1.26. So we have the review this security update. From the alert in the security tab, I can basically dismiss this. I can say that this is a fix already started and no bandwidth to fix this, risk external, and so on. So I'm going to review the pull request that I have for this. As part of the pull request, something that we have here is basically the information of what is the package that I have, the commit, and yeah, more information about it. Chris, I don't know, Charlie, I don't know if you would like to add something about this or the dependable pull request.
Nope, thank you. That's a really good display.
Perfect. Yep. All right. So yeah, for this we have the merge pull request, and because this is a pull request coming from that alert, once that I merge this pull request, basically I will be closing that. Let me delete the branch that I have here. I'll be closing that alert. So if I go back to the dependabot, you can see now that basically that alert got closed. So here we have the close fix now, and this is being closed because there was a PR open, and basically now it got merged. So I can see that this was closed with that pull request, and I can go back. And same for the rest of the alerts. So yeah, we can decide basically how we want to triage these alerts. And as you can see, we are now getting alerts from the code scanning. That means that the action that we have for CodeQL finished. So if we take a look at this CodeQL, we can see that we are running these jobs for each of the languages. And basically, as part of the jobs that we have here, the steps are basically build the application. This is Java, so it's building the application, and then it's performing the CodeQL. So let's take a look at the alerts that we have for code scanning. Here, basically, we can see this one, for example. We have the database query. This is presenting us information about what file was basically impacted with this alert. So in this case, we have the gallery-service main. This is for Go. So we have here Go, the rule ID, and it's a potential SQL injection risk that we have here. This is the tool that was basically found that issue. Here we have recommendations, example, how to basically close this. So yeah, the weakness enumeration information. So if I click this here, I can get even more details about what is this weakness and so on. So in order for me as a developer to fix something like this, I can basically create an issue and track this and basically assign this to myself. So let me go here and assign this issue to myself. And I'm going to submit this new issue. So now it's basically the issue number 8, and it's related to the database query build that we have here. So if I open this link, it's basically the same alert that we were reviewing later. So now I will open this in VS Code. I already have cloned the repo. So here I have the main.go issue, and as you can see, I'm selecting the line that was infected with basically the SQL injection attack. So as Chris was mentioned, something cool about GitHub is that it's focused on the developer approach. So for this, I'm using GitHub Copilot, and with GitHub Copilot, I'm basically with the chat option, I'm asking like there is basically a potential SQL injection risk in my code. How can I fix this? So GitHub Copilot is basically taking a look at the code snip that I have here, and it's telling me, okay, yeah, you're correct. The update function in your code is vulnerable for SQL injection because it's using formatting. So in order to solve this, I need to basically start using parameters. So with that, I can basically just paste this, and now I have basically the solution for that. So let's assume that I don't know what is a SQL injection attack. I can also ask GitHub Copilot. So for this, what is a SQL injection attack? And GitHub Copilot will basically take this reference and explain what is a SQL injection attack. So I can not only fix the issue, but I can also learn and get examples of how the SQL injection works. So now I can save this issue, save this file, and I'm ready to commit. So git commit, and I can put here basically fixes issue number 8 related to SQL injection. Oh, I need to git add. It's important. Okay, and now I'm gonna do a git push. The branch that I'm using is not in the remote branch. So something nice about Git is that giving me the command that I need to push in order to create this branch in the GitHub. So now basically I'm pushing the code. And with that, I can go back to my GitHub repo. Let me see. Okay. I can go back to the GitHub repo, and I should have the branch created for fix SQL injection. I'm gonna create a pull request, and we're gonna specify like this: fix the issue number 8 related to the what that we have here. It's okay. Create a pull request, and now I can merge this. And once that I finish this process, basically the CodeQL, because I merged into the main branch, the CodeQL will execute again. And this action will find out that basically there is a new fix for that security vulnerability. And now it will close the code scanning alert automatically for me. Right now, it's basically still there. But as you can see, basically, I'm tracking this with the issue number 8. As you can see, this is closed because I specified that this was fixed with the PR that I just merged. So while this basically executes, we are going to explore the secret scanning vulnerabilities that we have here. So as you can see, we have alerts for AWS keys that were exposed as part of the Git history. So that's great. I can see basically where this key was found. So in this case, it's for the storage count in the storage service. Okay, so I can close this as revoke if that key is no longer valid, or specify that this is just used in test, or basically false positive, and so on. But something cool about this is if I go back to basically one of the code that I have here, let's say that I open the config.json and I edit this file. Let's say that for this database, instead of using the local database, I will copy the connection string that I have for my Cosmos DB. So I'm going to copy this and paste it here. And when I try to comment this in the main branch, okay, I will receive an alert saying that this basically commit is blocked because there is an Azure Cosmos DB key that is potentially found as part of this commit. So I can say like this is using test, false positive, or I will fix it later. And then I can allow this secret. As an admin of the repo, I can also block the commit at all. So yeah, that's part of the functionality that we have. So yeah, that's basically GitHub Advanced Security features covered. Something else that we can do is integrated with Azure, with Microsoft Defender for Cloud. Here we have, for example, the Microsoft Defender for Cloud, and we have the DevOps option here. So I can integrate this with my repo in order to get basically a centralized view of all the different alerts that I have. So here are all the repos that we have. And yeah, with the Microsoft Defender for Cloud, basically I can see like these issues here. I can receive the alerts, see the active recommendations. So it's basically a more like centralized alerts for GitHub Advanced Security. Right? Charlie, something else that you would like to add?
Nope, that was a very nice demo. Well, yeah, that was a very nice demo, David.
Awesome.
I just want to add that with CodeQL, one of the really cool features that we saw there was that the developers, we're not just throwing the results over the wall to the developer and saying, hey, go fix this. We're giving them the information they need, both in the additional information that was shown when David clicked off of the alert, and then also with Copilot, as he showed in the IDE. So not only are we giving the developer information on how to fix the problem that they have introduced, you get a positive feedback loop, right? The developer learns about how not to introduce this problem in the future. Another really cool thing is that with the PR experience, the fact that when we're scanning on the PR, we're stopping these things before the technical debt is introduced to your default development branch. So it's very useful to keep that out of the development branch and find it while the developer still has the context of what they were working on in their head, right? They're not coming to this a week or two later and having to figure out, okay, what was I doing? Why was this? This is all happening before the code ever gets merged back in. Thanks, David. That was a great demo.
Awesome. Thank you. All right. And now I'm going to hand it over to Natalie to cover basically the different services that we can do for GitHub Advanced Security to help enablement and train customers interested in enabling these features. So.
Cool. All right. Well, I will try to keep this short and sweet, but basically security is at the core of everything that we do as Xpirit, and GitHub is our developer platform of choice. As an organization, we are all in on GitHub. So we're always looking for ways to help our customers shift left security in their development practices to make sure that security is incorporated both early on and more frequently all the way through from end to end. So because of that, we've enabled tens of thousands probably of developers worldwide of how to use GitHub Advanced Security in a way that's really impactful for their organization. We've worked with companies that are really small, we've worked with companies that are really big, and we've kind of done everything in between. And what we've learned from that is that sometimes getting started can be the hardest part. So because of that, we've put together a pretty curated offering that's focused on how do we help organizations move quick, and how do we help organizations get started on GitHub Advanced Security, but more importantly, be successful and really take advantage of everything that it has to offer. So here we have an offer that covers three primary parts that I'll go over. There's a lot of words, but to summarize, it's three pieces. We go through expert-led training, we go through a hands-on proof of concept, and results review and advisory services. So what this means in reality is that we start with education and enablement to make sure the teams know what they're getting into. We know that it can be a bit of a learning curve. There's a lot of things to know before getting into it. But step one is just really getting that foundational knowledge and understanding what GitHub Advanced Security has to offer and how you can use it in an impactful way. So step two is identifying a team where this is going to be rolled out pretty intensely and make sure that a team is fully onboarded and taking advantage of everything that Advanced Security has to offer. So after that, we give the team some time to really get sticky with it, understand, and then we move into sort of, okay, what came of that? Let's look at the results. Let's work together and make sure that you're using it in a way that makes the most sense for your team. And that's when the advisory services come in and we're able to jump in and help with anything that maybe is unclear, anything that's still sort of open-ended, just to make sure that all teams are really given the tools to be successful with advanced security in all the ways possible. So this is just sort of our jumpstart and how we get started. So if anyone has any interest in learning more about this and how this can fit into your organization, feel free to reach out. And because it's October, which is Cybersecurity Awareness Month, we're actually running a promo on this, which means you might be eligible for a discount. So yeah, don't hesitate to reach out if there's anything we can do.
Awesome. Thank you, Natalie. I just wanted to give us, I know we are tight on time, but I just wanted to give us a few minutes for questions, comments. You can type them into the chat. I know Chris prompted you guys to do so. If you guys have any questions, you can reach out to me directly. I'll put my email in the chat. Also, the landing page for this event will also have the recording of the webinar, so you can always refer back to it. And of course, there's a form there. You can always submit questions, or if you guys need anything else from us, you can submit that on there as well. I just wanted to check and see if we had any questions. So far, it looks good. I see Chris submitted his email as well. So if there's anything that we can do to help, definitely just let us know. But I hope you guys all have a great rest of your afternoon. Thanks. Take care.